For the last video, I'd like to make a microscope. And the way we're going to do that is using a compound lens system involving our lens number 1, which we're used to. This is a focal length of 10 centimeters. We've got lens number 2 here, which is basically the same thing as lens number 1. It's got the 10 centimeter focal length. I just needed to label it for number 2. And the last thing I'm going to need is a slide. So this is a piece of film that's got a tiny, tiny piece of black on it that has text inside of it. And we're going to try to read that text using our compound system. So the first thing we're going to do is we're going to stick our object at the 10 centimeter mark. So this is the film paper that we're going to be trying to read. It's going to be at the 10 centimeter mark. Next, we're going to stick lens number 1 at the 24 centimeter mark. You'll notice that this is the object and this is the lens, and the lens is outside of the focal length being 10, so no, more than 10 centimeters away. So what that's going to do is it's going to produce a real image somewhere back here. In fact, let's get our backboard in so we can actually find that image real fast. There we go. Find a nice focal spot here. Right about there. Okay, so that is going to produce a real image of the film onto this. And it's magnified, but it's still a little too small for us to be able to see. So what we're going to do is we're going to stick a lens number 2 and going to use this thing as a magnifier. And so we're going to stick it inside of the focal length, so it's less than 10 centimeters away from, this is going to be now the new object for this lens. And we're going to take that and create a virtual image somewhere back here. Alright, let me get this backboard out of the way. Stick this back. So here, we're going to be looking down the barrel of all of our lenses now. And we're going to try to look inside and see that virtual image. There it is. I'm going to zoom in a little bit. There it is. There, and if you can't read it, it says physics is fundamental, spelled with PHs, of course. Nice. And let me go over our complex system one more time, because it's kind of a mess. So here we have our object of film paper, which reads physics is fundamental. We've got our lens number 1 some distance away. This is at the 24 centimeter mark, it looks like. And that creates a real image somewhere out here that we're going to use as the object for our next lens, lens number 2. And it's going to be some distance away. You're going to have to calculate it. But lens number 2 is sitting right about here. That helps you read it. Okay, and that's going to take our now object, and it's going to create a virtual image somewhere back here that is a very much more magnified version of that image. And if we look down the barrel of lens number 2, we'll be able to read a much magnified version of our tiny little photographic film paper. This is how a microscope works, by the way. It's a compound lens system that we're able to magnify images well beyond the capability of one lens. Alright, so for question number 8, I'd like you to calculate the total magnification of the lens system. And the way you can do that is you can take the magnification due to lens number 1 and the magnification due to lens number 2, and you can multiply those two numbers together to get a final answer. For question number 9, is the original slide upside down or right side up? If we're able to read it normally. Alright, answer those questions and I'll see you in the next lab.